Okay, so first we're going to answer, we're going to go over the homework and do number 19 and number 31. So 19 is really tough. So this is supposed to be, is it x squared or just x? Just x. Whew, boy, that was going to really be hard. So this is actually supposed to be what we call quadratic form. So even though you don't see an x squared in there, so it's not really a quadratic, it has the form of an x of a quadratic. So there's a couple ways to conceptualize this. So I'm going to first say, imagine that we were going to say, and you don't have to do this step, I'm just doing this to make it hopefully make sense. But if you've done a couple, maybe you can see through this step and not have to do this. But if I said that y was equal to the square root of x, then what would x be in terms of y?
Y squared.
It would be y squared. You see that? Because if I square both sides, then x is going to be y squared. So then this could be, and we're trying to find where this is 0. We're trying to find the zeros. So this would become y squared. This is what we have called y, and the 12 doesn't have any y's in it, so it's unaffected by what we call y. Now this is something we know how to factor. Okay, we're in familiar territory. So we could go ahead and factor this. And so then we can see this is going to be, I think, y minus 4, y plus 3 if you do your box and diamond thing. Now what I'm going to do is going to set these both equal to 0. So y minus 4 is 0, y plus 3 is 0. But now I'm going to go back and I want to plug in these, I'm going to go back from the y's to the square root of x's that they represent. So this is really square root of x minus 4 equals 0, and square root of x plus 3 equals 0. We okay? Tell me if I'm going too fast. Now, when you solve this one, we add the 4 to the other side. We can square both sides, and we'll get x is 16. No problems there. Now, the other one, you got to be careful, because when you subtract the 3 to the other side, you're looking at square root of x is equal to negative 3. Why is that a problem? Is it a problem?
Because a square root can't equal a negative number.
Exactly. This is a principal square root, which means it can't equal a negative. Now, if you square both sides, you're going to lose that, and you'll get an answer. You'll get x equals 9. But 9 does not make this a true statement, right? Square root of 9 is 3 plus 3 is not equal to 0. So this, in fact, will never be equal to negative 3. Square root of x will never equal negative 3. So there is no solution to this piece. So the only answer is going to be x equals 16. Now, when you see, after you've seen this a few times, the hope is, maybe it never happens, but maybe it can be too, where you can skip this step and just see, oh, I see this as being square root of x squared, and then jump to factoring that as the square root of x minus 4 times the square root of x plus 3, and see that the square root of x times square root of x is the x, and 3 square root of x minus 4 square root of x gives you the negative square root of x, and the negative 4 times 3 is negative 12. On the other hand, we're not going to do that many of those, so you can still do that kind of substitution thing. Is that okay? Now, next problem, to check on concavity, remember we're looking at rates of change. So we can look at these two and say, what is the rate of change between those 2 points? So we're going to subtract the y, so we have 4 minus 2 over 3 minus 1. So that's going to be 2 over 1. So this rate of change is 2. And we're moving from left to right here. So x value 1 is left of 3, which is left of the x value of 5. So we're looking at this curve going from left to right. Rate of change there is 2. Now we do the rate of change here, and we're going to get 2 minus 4 over 5 minus 3. So that's a negative 2 over 2 is a negative 1. So we can see the rate of change is going from 2 to negative 1. So is the rate of change increasing or decreasing?
Decreasing.
Decreasing. So because the rate of change is decreasing, is this function going to be concave up or concave down? Concave down. So that's how we know the function is actually concave down. All right? Anything else from the homework? Yes, Ron.
33.
33. You know what that is, or do I need to?
No, I think it was something with, like, it's a quadratic problem, but I also have C in it, where I have to solve for C.
How confusing. So 33 is going to say, without a calculator, graph the following function by factoring and plotting zeros. we have y is equal to negative 4cx. So y equals negative 4cx plus x squared plus 4c squared plus x squared plus 4c squared. And we know that c has to be positive. Okay. And what are we trying to do again? Graph the following by factoring and plotting zeros. So we're going to graph, and they're telling us, they're giving us a hint to find the zeros. So what that means is we want to set this equal to 0. Now I'm going to change the order a little bit here. I'm going to write the x squared first, then the minus 4cx, and then the plus 4c squared. Okay. So it looks like, now if we're going to be open-minded here, and see through the abstractness of this, can we factor this thing? I think so too. Should we do your box and diamond? So this is going to be the word c squared x squared. You might just write the 4c squared. And this is going to be a minus 4cx, or you might just write that as a minus 4c. So what's going to multiply to be 4c squared and add to be a negative 4c? Negative 2c and negative 2c. That okay? So now doing your box, right? So you've got the 4c squared x squared. We're going to put the 4c squared here, and we're going to put a negative 2c in each of those places, or however you do your diagonal. So we want to know what's going to multiply to be this. Well, so let's get our greatest common factor out of these terms. 2c. Oh, this had an x in it, I guess, because we had a 4cx.
Wouldn't it just be x squared for the top left box?
Have it your way. Yes, sorry. I don't do it this way, so I forget sometimes how to do this. Okay, now what's the greatest common factor? X. Yeah, that sounds better. What's this going to be? X. So then what's this going to have to be?
Negative 2c.
And what's this going to have to be? And to confirm, these should be that, and they are. So it looks like it's going to factor into x minus 2c times x minus 2c. And that's now our function. Or if you want, you could write it as x minus 2c squared, either way. Okay, so now we're going to try to graph this thing. So where is its x-intercepts? Just 2c, and there's only one x-intercept. Well, c's got to be positive, so that means 2c's got to be somewhere to the right, and we don't have any scaling, so right there clearly is going to be 2c on my graph. And is this probably going to open up or down? Up, because it's a positive x squared, and I don't have any scaling, so I can hardly go wrong, and there we have it. Crazy? That's a tough problem. What else?
On the notes we took yesterday, I was kind of confused what negative b divided by 2a represented. Was that how you find vertex?
Yeah, so so far we've got 2 ways of finding the vertex. We're going to add a third one today. 2 ways to find a vertex of a parabola. So one is you can just know that the x-coordinate of the vertex is going to be negative b over 2a. And then you just plug that in to find the y-coordinates of the vertex. And the second way is if it was given to us in factored form, then what you are going to do, I think I call that R and S. What you're going to do is, find out where those x-intercepts are, and then go halfway in between, and then plug in that value. That's actually what you're finding is negative b over 2a that way. Now, do you see where the negative b over 2a comes from? Okay. So you can remember that. It's hard to remember, you know, after a month or two when you haven't graphed a parabola. I don't know who goes a whole month without graphing a parabola, but I guess some people do. So if you have a hard time remembering that, it comes from the quadratic formula. And nobody can forget the quadratic formula. That's the assumption here. Okay. Other questions? Does that help, Parker? Does that answer the question? Okay. Now we're going to get a third way of finding the vertex today. So we're gonna put a parabola into vertex form. So this is actually section 3.2 in our book, vertex form of a parabola. So vertex form is y equals a times x minus h squared plus k. That's known as vertex form. And so this is really, I mean, this is exactly what we have talked about in terms of our translation stuff with any function. So our parent function here is the squared function, x squared. And we know that if we translate that over h and up k, then that is going to be y minus k equals x minus h squared. And then if we just move the k to the other side, then it's going to be x minus h squared plus k. And now the vertical stretch or shrink, which we haven't really talked about generally yet, but you saw in your algebra 2 days, you can get that by multiplying here. So the h and the k is going to be the translation, and the a is going to determine whether it's going to be a stretch or shrink vertically or horizontally. So if we start with, you know, our parent function that's a parabola, you know, where we got this parabola with the vertex at 0, 0, then what we see from the hk is that's where the vertex is going to go. So we're going to move it, you know, over h up k, and that's going to become the vertex of this parabola here. And then the a is going to decide, you know, since a parabola looks a basic x squared parabola, you hopefully have a picture in your head. Then if the a is bigger, it's going to narrow it, okay, which can be either thought of as a vertical stretch or a horizontal shrink. It has the same effect. And if a is less than 1, it's going to be wider or flatter or fatter, however you call that, compared to a y equals x squared. Okay, so the a determines the shape, and the h and the k is going to place where the vertex is. So the question then becomes, you know, they're given to you, you know, that's a real gift, because then the vertex is typically, the vertex and the x-intercepts are usually the hardest things to find. So in the case we talked about last time, where it's given to you in factored form, you're kind of gifted the x-intercepts. You can just see them from the graph, and then you just find the halfway point to get the vertex. When it's given to you in vertex form, you're gifted the vertex. I mean, you just read it from the graph. Of course, rarely are you given it in this form. And so our question is going to be, if you don't have it given in this form, how do you put it into that form? And that's going to involve what we call completing the square. So let's see what that looks like. And there's going to be some complications along the way. So let's find the vertex. And I'm going to say find the vertex, and I'll direct you by completing the square. So this process that we are doing is called completing the square. So we're going to put it into that vertex form that we see there, and then we're going to say what that vertex is. So I'm going to start with a very basic one, and then we'll go to more complicated ones. So here's a standard parabola. Now, the reason this is a more simple one is because the leading coefficient, the coefficient of x squared, is 1, and that makes it especially nice. That's not going to happen very often. So what we do then is we are going to save the terms with x in them. We're going to push the -3 off to the side. And then we are going to make this so that it's going to factor into a perfect square. And the way we do that is by completing the square. That's called completing the square. So what we ask ourselves is then, once we have made this leading coefficient +1, which this was already given to us that way, we're going to take half of the middle term and square it. So we're going to take half of 6, which is 3, and square that. And that's going to be a 9. So we're going to add the 9 in there, because that will make this factor into a perfect square. But of course, you can't just add 9 into an equation. You change the value. So I could add 9 to the other side, but I don't want to mess up the other side. So I'm going to turn around and subtract it back off. So the net change is 0. I added 9 and I subtracted it back off. I just added 0 to this equation. That doesn't change its value. We're just going to mess with its appearance. Okay? So now we have built this so that now it's going to factor. So now this will factor into a perfect square. That was why we chose half the middle term squared and added it in there. Now this is always going to factor into x, because our leading coefficient was 1. It's going to be the same sign as this middle term. Plus if that's a plus, minus if that's a minus. The number that goes here, these will agree. Either half of this or the square root of that. Those will give you the same number. Half of 6 is 3, square root of 9 is 3. That's the number that goes there, whichever way you want to remember it. Or you can do both and make sure it really is working. Now when we get out, here's what we get. Negative 3 minus 9, in this case, is a minus 12. We got into vertex 1. And so the last thing we're going to do is say, what is the vertex? Don't forget to answer that question. So that vertex, so here's the H, here's the K. It's going to be the opposite of what you see here. Same sign as what you see there. There's our vertex.
Wouldn't it be x plus 3 squared?
You are correct. I was just seeing if anybody was paying attention. Thank you for not letting me give that as the wrong example. That would be better. Plus because this is a plus. Okay, and so that makes that a negative 3. Make sense? Okay, well that was the easy one, the warm-up. Let's do one that's more challenging, because we enjoy a good challenge. So let's make the leading coefficient not be 1. So let's go y equals negative 2 x squared plus 8x plus 1. So here is our parabola, and we're just going to try to find the vertex using by completing the square. Now once you do that, we can still do the whole graphing thing. So you can still go find the x-intercepts, find the y-intercept, the symmetric point, and all that stuff. But the hard part is getting to the vertex, I think. So now we don't have a leading coefficient of positive 1, so we're going to make that into a positive 1 by factoring out whatever is in front of the x squared. But only out of the x terms, because this isn't the constant we want. We're going to kick it to the curve. We're going to boot it outside the part where we're going to do factoring. So I'm going to leave this, and then I'm going to push the plus 1 outside there. So, and I'm not factoring the greatest common factor. I know I could pull out an x. That's not my goal. I just want to make the coefficient of x squared positive 1. So when I factor out a negative 2, this becomes x squared. What happens to the 8x? Factor out a negative 2. What's left is negative 4x. And I'm leaving a space because I'm going to complete the square. Okay, with me so far? Now, we do what we do. To complete the square, we're looking here at the middle term. Half of 4 is 2. 2 squared is, it's always going to be adding a positive, so I'm going to add the 4 in there. Now, here's the tricky part. I added 4 in the parentheses, but that 4 is getting multiplied by negative 2. What I have added to this side of the equation is not 4, it's negative 8. To balance that, I'm going to have to turn around and add 8 to make the net change 0. You with me there? That's the part that throws people. You got to have a net change of 0. Adding 4 here, I multiplied by negative 2. I've added a negative 8 into the right side of the equal sign. So I'm going to balance that with a plus 8. Now we got it. So now we're just going to say y equals negative 2. This is going to complete the square. I'm going to try to do it right this time. It's going to be x minus half of 4 is 2. Square root of 4 is 2. They agree. And on the other side, and outside the parentheses, we just get 9. So don't forget to say what your vertex is. The vertex is going to have x coordinate positive 2 and y coordinate positive 9. Different sign, same sign. Is that okay? All right, let's do another hard one. Okay, erase, destroy the evidence. Let's do y equals let's go, you're gonna like this one, 2x squared plus 6x minus 5. All right, what do we do first?
Factor out the 2.
Factor out the 2. Push minus 5 outside. What's left is
X squared plus 3x.
leave a space. Okay, am I going too fast? We all right? Emma, we okay? Now, here's where it gets ugly, right? Half of 3 is,
1.5.
you guys are afraid of fractions. We have to overcome this fear. Half of 3 is 3 halves. Half of 3 squared is going to be
9 4.
9/4. We're going to add in a 9/4. I can just feel the tension rising here. This 9/4 gets multiplied by 2.
18 4.
That's philosophically opposed to canceling here.
Oh.
9 halves.
Yep.
So adding in 9/4 here really adds in 9 halves. We're going to balance that by minus 9 halves. Follow all that? Or you're going to have fun with this. So now we get y equals 2 times, okay, it's going to be x
Minus 1 plus 1.
plus,
1.5.
what?
3 halves.
Oh, okay, 3 halves. You can use 1.5. I'm just messing with you. And then we're going to get, more chance to do fractions. Common denominator, 5 is how many halves?
10.
Negative 10 halves minus 9 halves is?
19 halves.
Ah, you get the hang of it. Okay, so our vertex is,
Negative 3 halves.
comma,
Negative 19 halves.
ugh, gross. Okay, let's do one more quick one. You ready? Let's do y equals 1/2 x squared plus 3x minus 2. Whew, more fractions. This will be fun. I know how you feel about fractions. Okay, what do we do first?
Factor out the negative, or the 1/2.
Factor out the 1/2, the coefficient of x squared. This is going to take some thought. Pushing the minus 2 out because we're not going to be included in the factoring stuff. Took out the 1/2 out of x squared. What's left is?
X squared.
Now think, if you factor out a 1/2, what happens to the 3?
Multiplied by 2.
Yes, to divide by a half is to multiply by its reciprocal. The 3x is actually going to become 6x, right? Think about it. Half times 6 takes you back there. Oh, that wasn't so bad. Half the middle term is, squared is, that 9 just multiplied by,
1/2.
so we're really adding in,
9 halves.
so we're going to balance that with a
Negative 9.
negative 9 halves. So we have y equals 1/2. This is going to be x
Plus
plus 3 halves, because the 3
3
halves is, oh, not halves, oh, no, plus what?
3.
3. That's half of the 6 or the square root of the 9, either way. And then we get, let's see, negative 2 is how many halves?
Negative 4.
Negative 4 halves and negative 9 halves is?
Negative 13 halves.
Okay. So our vertex is going to be,
-3, -13 halves.
very good, very good. Can't believe we did it, but we did. Oh, 3 different ways we have of finding the vertex. X equals negative b over 2a. When it's given to us in factored form, we're going to take that point halfway in between the x-intercepts and then be able to put it into vertex form by completing the square.